Today we're going to continue on with parallel line development. We're going to look at T's. Now I've got a T drawn on the board here, and what we're referring to as a T is a piece of pipe coming off another piece of pipe. So this here, this portion is the T, or this one or that one, and this is the pipe. So the main piece is the pipe, and the takeoff or smaller piece on it is the T. Okay, so I have that drawn here. As we'd see in sort of an orthographic projection type of a view, we got a front view here, or front elevation. We have a top view, or plan view, and then we have the right side view. So looking at this one from here, or this way. So we get those three views. Now, when we go to layout or perform pattern development, this is quite cumbersome. There's a lot of overlays in the drawing where we don't necessarily need it. And that's what we're going to look at first, is where we can get rid of some information to simplify the drawing a little bit for us. Now, on our last one, we merely looked at an elevation view and a top view or plan view, and we could actually scrub away most of the plan view and go with profile views. So that gets rid of this view for us. It doesn't do a whole lot for us. So let's remove that one out of our view. And we'll find this with a lot of drawings is when we think of third angle orthographic and those three views, a lot of the times we have views we don't need. So if we have just a cube, one view gives us all the information to it. The other two views are going to be duplicates. So they're not necessarily required. But two is a pretty standard. You would always, or in most cases, need at least two views. So we, for the T, we have our front elevation and then an end view or right side view. So that gets us to a point where we can see what we need from this. And what we want to establish is the miter line that comes down where the T intersects the pipe. Okay, so we need this view. And the end view here shows us exactly where the T hits the pipe. And it gives us this view here, which we don't have there. So we're gonna require this one as well. One thing with any T, and it doesn't matter what configuration it is we never need the bottom half of the pipe on any T. So we can remove that. It's impossible for a T to wrap around the pipe after the point of tangency at center. So we'll leave the center line and remove anything below that. And now we start to get to a much more simplified view of what we need to establish, which again is this miter line here. So we can start some of our line work now. And the first thing I want to do is establish some profiles to give us some lines that we can then establish our miter line from. So I'm going to profile the T. And that's an important note, is when we're doing parallel line on a T, we never profile or divide the pipe. It's always the T that we're going to deal with. I'll come over and do the same on this view here. View, and that's where we can really see where I won't be profiling, I won't be dividing this part here. That's the pipe. So the blue is the pipe. We don't want to divide it up. I wanted the divisions in the T because that's what I'm going to make. And that's where if we think ahead, our stretch out or our blank size will be the T. So that's what we want to divide. And then let's put some numbers on here. Remember, we always use numbers for round, letters for square items. Now I'm gonna wrap it around and keep my numbering going. And we saw this last time where I scrubbed out the half of the plan view, and I went with just 7 numbers. But this case we want to go with all 12 for now. Now if we look at this one here, and if we're imagining this pipe here, this is 0.4 on here like that, and this view is swung it around. Look what happened to 0.4. 0.4 was there, and now it swings. It's on the left-hand side now. And 10 was back here, and as it swings, it goes to the right-hand side. So a good starting spot for labeling the end view is taking our 410, and remember they're like this, right on center, and we've spun this view now, and now they're on the outsides. So I'll start 4 and 10. I also, just opposite to that, I had 1, 7 on the outsides. And again, if I had 1, 7 here, and I spun it, 1, 7 end up on center here. Like that. And now we can just fill in the blanks between, still following our number line. So if I have 1 here and 4 here, I know that this needs to be 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there we go. It's a lot of numbers to look at once, but what we want to take from this here now is how that view spins and rotates around, and our number system has to follow that. Okay? So I'm going to continue with my element lines because I still need to establish and finish off my miter line here. So what I'm going to do is find, say, 0.1 and 1, and those lines need to come together now. 1 and 1. So 1 here, that needs to come across, and that's at the peak of the pipe. We'll bring that across here. Two and 2. So where will those meet? We bring that across. Three, 3. 4 comes all the way to the bottom and across. 1, 2, 3, 4. 5, 6, 7. And we can draw that in. This one will end the miter line, and just like our pipe on a miter, will be a straight line here, but will be a curved line when we actually get to our pattern. So now we have our miter line established. We see this, and just back from our pipe on a miter, what we're looking for when we're doing parallel line development is the height of our element lines. So we need the height of all of these lines here. To establish our pattern. And that's what we're going to transfer into our stretch out. So the green lines is what I'm looking for. And because we have this top of T here, and that projects over, we have the same height here. Because all of these points were projected. That view was projected around. So our height hasn't changed here. So that means that these lines are the same height as the other view. So now we have line 1, and we have line 1. Same height. Line 2, line 2, 3, 3, 4, 4, and all the way through. What the miter line does is go through the front side of the pipe, and then it mirrors itself on the back because this is an on-center T. So the miter line, we see one of them here, but really there's a second one overlaid there. And that would be our points 8, 9, 10, 11, 12 on the back side, as we see down here. So we look at that and we still see it's a little bit cumbersome. There's still a lot of line work there. Okay, and doing a full plan, full elevation view, or the two views you require for any T or any parallel line project is a good place to start, to learn the process, to learn the concepts of it. But we can start to see where we can shortcut things, and we did that a little bit on our last drawing, so let's do it here too. Now, if we want the heights, we have 4 lines, 1, 2, 3, 4. And then 3 and 5 are duplicates, 2 and 6 are duplicates, 1 and 7 are duplicates. So that tells us that we have 1/2 of this that's extra. So maybe I take out that half. Okay, that would tell us that we could get rid of 1/2 of here, because again, we have 1, 2, 3, 4 lengths, and the other side are duplicates. So if we can scrub that out. We get that. Now when we establish the miter line, again, now we have our 4 lengths here, and we have a duplicate of our 4 lengths here. So that tells us we can get rid of this whole view here. So if we take it down to that, and we're left with a quarter or half profile or a quarter plan view of we have the T here and then the pipe down here, and we still get the 4 heights that we need. Okay, and that's a much simpler version of going and finding our pattern. From there, we can start to establish our stretch out. Okay, so now I have my quarter views here, I have my stretch out, and we want to start establishing our pattern. Again, if we're looking at this T here is what we started with, and this is equal diameter 90-degree T, meaning the pipe and T are the same diameter, same size, and it's straight, it's perpendicular off the pipe. What we normally choose on something like a T is we put our seam on the shortest side. So the seam would go at the very top of the pipe. And there's really not much reason for that besides the shorter the seam, the less work to do. So I can now take, and if I want my seam at the top of the pipe, here's the top of the pipe here, I'm going to start my numbering at 1. So I'll number my stretch out. In this case, again, I only have a quarter circle, but I'm going 1 to 4. And then I would come back this way, but I'll just turn around. So I go now this way. 1, 2, 3, 4, 3, 2, 1. And then I turn around again. 2, 3, 4, 3, 2, 1. We start and end at the same spot. That will come together and make our seam. So again, 13 lines make 12 equal divisions. And I've just gone around the quarter circle 4 times. 1 to 4, and then back to 1, and then back. And then we had a second turn around here, stopping at 1 again. And now I project my lines in. So I go 1, 2, 3, 4 is at the bottom. And I'll just use those lines to further my drawing. Again, we can project. We can project our lines or use our dividers and pick up those lines. And there's our pattern there. So again, using a flexible curve, I don't have one in here, so I use freehand, but don't do that on your drawing. When it comes to the bottom of the pipe, which equal diameter does, it's going to just end. Okay, there's no turnaround like we talked about on the pipe on a miter or coming out here. At this point, we know that it's going to return down because that's what it does here. So this one we want to taper off again and get ready to come back down because it's going to come down on this side here. But when it hits the bottom of the pipe, it just ends. And then we end up with a bit of a point. And there's our pattern. That would be an equal diameter 90-degree T.